Today we're going to be talking about optimization in business and economics. Previously, we have talked about relative extrema, and now let's talk about absolute extrema. The value f of a is the absolute maximum of f if f of a is greater than or equal to f of x for all x in the domain of f or over the interval of interest. The value f of b is the absolute minimum of f if f of b is less than or equal to f of x for all x in the domain of f or over the interval of interest. So let's look at a rough sketch of a graph. So here's my y-axis and here is my x-axis, and let's say I have a function and I'm looking over the interval from a to b, and it looked something like that. So let's highlight some points. If we're looking from a to b, then this point here is a relative maximum. This point here is a relative minimum. But notice here, this is the tallest or highest point, so that is called the absolute maximum. And then this is the lowest point on our graph over this interval, so this is the absolute minimum. Example 1 says the total revenue in dollars for a firm is given by R of x equals 4000x minus 40x squared minus 2x cubed, where x is the number of units sold per day. If only 50 units can be sold per day, find the number of units that must be sold to maximize the revenue. Find the maximum revenue. So the first thing that we want to do is we want to find the derivative of the revenue function. And when we do that, we get 4,000 minus 80x minus 6x squared. And we want to set that equal to 0 and solve so we can find some critical points and then figure out whether those are minimums or maximums. So I'm going to take our derivative function, I'm going to reorder it. And then set it equal to 0. And I am also going to use the quadratic formula to solve this. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So we get 80 plus or minus 80 times 80 is 6,400 plus 24 times 4,000 all over negative 12. That ends up equaling 80 plus or minus the square root of 102,400 over negative 12. And then let's take the square root of that number. And that gives us 80 plus or minus 320 over negative 12. From there, we'll get two answers. We'll get 400 over negative 12 and negative 240 over negative 12. And this ends up being negative 100 over 3, and this ends up being 20. Now, remember that x represents the number of units sold per day. So in the context of this problem, saying that x is equal to a negative number doesn't quite make sense. So we're basically left with x equals 20, but we need to verify that that's going to give us a relative maximum or a relative minimum. So what we can do is we can use the second derivative test. So first we need to find the second derivative, and that gives us negative 80 minus 12x. And so if we evaluate r double primed of 20, we get negative 80 minus 12 times 20. And I don't need to exactly solve for what that number is. I just need to recognize that whatever it is, it's going to be negative. And so if it's negative, then the graph would be concave down, and we would have a relative maximum. Now, the only other thing we need to be concerned about are the endpoints. So if you look back at this graph that I've drawn previously, it could be the case that maybe this is 20 here, and we are getting a relative maximum, but we need to take into consideration the endpoints here at A and B, because we could have a higher value like we do here, where this is an absolute maximum, versus this here, which is just a relative maximum. So all of that is to just say that we need to take into consideration the endpoints. So in example 1, it says if only 50 units can be sold per day, that means that the interval that we're looking at for this problem is the number of units ranges between 0 and 50. So we want to go ahead and plug in 0, and we want to plug in 50 to make sure that those are not potentially giving us a higher value. So let's come down here and let's evaluate r of 0. So if we go back to the original function, we'd get 4,000 times 0 minus 40 times 0 squared minus 2 times 0 cubed. And all of that just ends up equaling 0. So that's probably not going to be our maximum, but we do need to check r of 20 and r of 50. And so I'm just going to throw those into a calculator really quickly and see what we get. So r of 20 ends up being 48,000. And make sure that you are able to get the same number. And then r of 50 is equal to negative 150,000. So out of these three values, 0, negative 150,000, and 48,000, 48,000 is definitely the highest. So we can say that 20 units must be sold to gain a maximum revenue of $48,000. And that is the end of this problem.